Chaim Ben Ami. He is the CEO of RAFT Technologies. His presentation title is Shortwave Trading, Leveraging Revolutionary Technology for Ultra-Low Latency.
I founded an algo trading company back in 2007 and managed it for 7 years. We traded cash in New York and future in Chicago. Later on, I moved to manage a wireless connectivity company serving international companies around the globe. And I joined RAFT 2 years ago. So as you can understand, my personal background is both taken together, algo trading and wireless connectivity. RAFT itself was founded in September 2013. We are 25 employees based in Tel Aviv. Most of us are engineers. All the paradigm, VLSI, IT, system engineers. We own the IP and we developed everything in-house. The company, we own links. We have them now working for more than a year in production with the customer on them, and of course with all the relevant regulation and so forth. Let's talk a bit beforehand. This is the footprint that we have in each such venue, in each such place. We have a team that supports our activity to make sure that we can give the best service. Let's go into shortwave. So shortwave is actually an electromagnetic waves like the same one that we are using with the microwave, with Wi-Fi, with cellular. This is the same thing. The only thing is that it is at the lower side of the RF spectrum, 3 megahertz to 30 megahertz. By the way, if I'm saying HF or high frequency or shortwave, afterwards I'll use skywaves. This is the same thing. This is the same phenomena. Don't be confused about between these different terms. So shortwave is 3 megahertz to 30 megahertz. The regular application that you use are usually above 1 to 2 gigahertz. It has a meaning. We'll touch it later on. The phenomena that we call skywave is a unique property of a shortwave. For shortwave, the atmosphere, Earth atmosphere, acts like a mirror. So they are not going out to the outer space. They are bouncing back into the surface and then bouncing again to the atmosphere and so forth. This is why humankind could utilize such technology or such physics phenomena for long distance communication. It's still being used today, mainly for broadcasting, search and rescue, and so forth. And as probably most of you know, in recent years it was started to be used for trading. It's started to emerge or to develop roughly 5 to 6 years ago, but we started to see it in different blogs and in newspaper around 2 years ago. So why it's so good to use shortwave for algo trading? The answer is that it's enable us to arrive first to trade, to save latency. Wireless, the speed of light in air is 300,000 kilometers per second, okay? And in fiber, which made of glass, is 200,000 kilometers per second. This big difference between the speeds give us a very strong advantage in latency. And of course, when you take it to long distance, our links are between 5,000 to 10,000 kilometers. You can gain around 1.7 milliseconds in theory on each 1,000 kilometers that you are travel. And of course, there is the direct lines. In order to go from Chicago to Frankfurt, you don't need to go through New York or through London. You're going almost above the North Pole. So if we want to start to engineer such a system and to develop it, first of all, we need to understand what influence shortwave. And imagine yourself the channel that we are using between Earth and the atmosphere. This is not a fiber. It's a constant changing channel. And the main influence, of course, is the sun. The different layers in the atmosphere are constantly changing between day and night. This is one very important effect on what happens in the atmosphere. And other than that is the interaction with the solar wind. The sun activity manifests itself on Earth as solar wind. There's additional interaction with the magnetic field of Earth that, by the way, changes as well, not on a daily basis, but it changes as well. But these two phenomena and the interaction between them influence our ability to transfer information through the atmosphere. By the way, as you see below on the graph, the sun itself has its own cycle between 9 to 11 years. We are now in a period of low sunspot, of low sun activity, and this was one of the challenges that we needed to mitigate. I choose to mention 4 points that we needed to overcome or to tackle when we came to engineer such a system. First of all is the effect of distance on the strength of your link. The signal that we are sending decays very, very fast with distance. And our mission is to differentiate between the signal and the noise surrounding our receiving site. As the further you are going, the larger the distance, and as I said before, 10,000 kilometers, you receive a very, very low signal, and you need to find techniques to identify this specific signal. One of, for example, of the method that we did is we mapped the noise around us in order to be able to do later on interference cancellation, for example. So we are using AI in our field in order to map the noise in our surrounding. So this is, for example, one challenge while you are trying to build in a shortwave system. Another one is the low bandwidth. As you remember, we are at the low bandwidth of the spectrum. Lower frequency mean less frequencies that you can utilize in order to transmit your information. In order to mitigate this challenge, we collected and we picked up from different communication protocols methods of transferring information on a lower bandwidth, be it from a Wi-Fi, 3G, or a 4G. And it enabled us to condense more data on the lower bandwidth that we experience in the HF. Third one is error correction. For you guys, or for trading, error means immediate loss. So this is something that you can't, it's something that we can't cope with. On the other hand side, if we want to do error correction, we need either to take a part of our bandwidth or part of our latency. For example, we can do repetition in order to make sure that we don't have errors. But this is all about. I mean, we can't take latency from our system in order to correct the errors. Here we found ourselves developing a transmit or receive algorithm that were able to detect our signals and transmit it with a very, very, very low ratio. Today, our systems suffer maybe 1 error per day, which is very low and enable us to trade even with a very low frequency algorithms. The last challenge is as I mentioned beforehand, the open channel, as I called it. And in order to mitigate this challenge, we are doing channel prediction. We are doing prediction on how the atmosphere is behaving, and our system is automatically adjusted its parameter in order to maintain a stable link. Of course, we have someone that monitors the system, like you guys monitoring the algorithm working. We are the same from our side, monitoring constantly the prediction algorithm on the channel itself. So this is for the challenges. This is how our system is look like. Okay, we don't sell the hardware or something like this. We sell a service. From co-location to co-location, our customers simply cross-connect, to our switch. It's a basic UDP API, and of course the antenna We put them outside of the city. No one wants a large antenna near his house. And we build either microwave or a dark fiber from our site into the co-location. This is where we are today. We are on production with working customer between Chicago to London and Chicago to Frankfurt. Next to come is Chicago to Tokyo. But what's important for me to show you is where we think this technology or this industry is going. And our vision or what we see is going to happen is the same that happened with fiber or the same that happened with the microwave. We see very complex matrix or connectivity networks. From what we see, the same is going to be with shortwave. We identified around 30 links around the globe, some of them tier 1, some of them tier 2, some of them tier 3. By the end of the day, we assume that there will be demand to all of them. Okay, and this is going to be kind of a new benchmark for low latency. So the current status is that, as if you saw Stefan a presentation beforehand, he clearly show and explain why from he listening to the shortwave in Europe, how we understand that already 20 to 30% of the trading cross-Atlantic is being done by shortwave trading. Part of it, yes, this is by our customers. The demand is high and it can be for a different reason. There are some small companies that can't allow themselves to build very expensive networks and they're happy to receive it as a service. Others see it as a growth engine or to want to go to new regions with this specific technology. Each firm with its own reasons why they want to adopt such technology. And of course, there is always the consideration between build it yourself or rent it. In this technology is not different from any other technology. There are firms that are developing this technology in-house. It's not saying that they can't work with us, of course, like any other field. Last topic that I want to cover is several. How much do I have? Okay. Okay. Last topic that I want to cover is some lesson learned from working with such a system and servicing with it. So first of all, we had a very interesting discussion here in the round table. The latency advantage is huge. The discussion that we had here was how can you guys save 150 nanoseconds, okay? 1 or 100 micros, for example. This technology gives a millisecond advantage, okay? We are today given an advantage of 3 milliseconds on Chicago, Frankfurt, and 2 milliseconds on Chicago, London, okay? And this is something that companies that adopt this kind of service need to adapt to. It's relatively new. This is one lesson that we learned from using it. The other thing is that since the bandwidth is relatively low, you can't transfer meg of data. You can't transfer the book. You'll always need to support or to work with the fiber. The right way to use it is to define yourself a strong and important indicators that you will transfer to yourself. You remembered our system beforehand from co-location to co-location. You need to define your own set of indicators and transfer it to yourself. Very important conclusion from these 2 points, the fact that you have a very big advantage in latency and that you need to transfer only several indicators means that the bandwidth is not an issue. Anyway, for now. Our customers don't reach in the limit of our bandwidth or how much we can give them, and this is a very good news for everybody. There are some misconceptions that we receive a lot, and I wanted to talk about it. First of all, many think that weather influences this link. It's not. Weather on Earth does not influence shortwave. It's not like a microwave, for example. Okay, this is one thing. So it's working even if there is a fog or rain or storm or whatever you want. As long as your antenna were not demolished by the wind, it's working. Okay, this is the only thing. Misconception 2 is that we hear it a lot from radio amateurs or HF engineers that we are now in a period of low sunspots, and hence it's very hard to maintain a stable HF link. Again, it's not true. HF can work 24/7. It depends on your technology, your receiving, how much power you use, and so forth and so forth. And the third one is that the head path to the atmosphere consume a lot of latency. It's not true as well. It's not satellite, okay? The atmosphere is 150, 200 kilometers above us. So on a link of 7,000 kilometers, you can neglect this specific effect. So this is on the technical side. On the commercial side, a stable link is key for the technology adoption. The last thing that you want to see is that your quant waste their precious time and then the link is not up. We learned it very, very fast. I received many times the notion that HF is not stable. We assume, of course, if you use a system that was built by 2 to 3 engineers that can't support such complex system, yes, it will not be stable. This is why this is the only thing that we are doing. By the way, of course, we are not trading or something like this, and we dedicate all our time for the link stability. Otherwise, we know no one will use it. The adoption cycle of customers takes between 2 to 3 months. The initial cross-connect is around 2 to 3 days, but the adoption itself, to define the strategy, to gain confidence in this new technology, to increase volumes and to define it as a production, takes between 2 to 3 months on average. Depends on your firm. It can be used, as I said before, for either low-frequency trading or high-frequency trading. From what we see, it's better to use it for high-frequency simply because you have an advantage, so you want to hit it as many times as you want. To sum it up, we think that we are introducing a revolution to the market. We are a service company. Of course, we can't serve everybody. We are looking to work with innovative companies that want and can adopt new such technologies. We think that at the end of the day, this will be a benchmark and more firms will use it in the market. One of the most important things for us is the cooperation with our customers. We learn a lot from our customers, and this is a very important message from us to you guys. So thank you very much for your time, for listening.